Before we get started, I just wanted to give you a little bit of my background. I've been a data scientist for over 10 years, and I found Kukuyeva Consulting to help overwhelmed founders try to make more sense of their data. So after working with me on their data strategy and implementation, they're able to make their product more profitable, scalable, and more user-friendly. And in my experience developing a lot of customer-facing models, I found that I have to learn to make time for tests and try to make time for tests. And today we'll learn more about why do we need to do tests, why do we need to write tests, and how do you actually go about doing it. So let's get started. First things first. I want to talk about what happened at Knight Capital. So you may or may not have heard of this financial institution. So in 2012, they had a code base that they reverted to a previous checkpoint. And what ended up happening was anytime somebody went to fill in an order, it was not getting tagged as filled. And so in August of 2012, when they went to place 200 orders, they ended up placing over 2 million. So in the span of 45 minutes, they lost over $400 million. Their stock tanked by 75%, and they were also fined by the SEC. So we'll try to make our code more robust and more testable so that that doesn't happen to our client. So what's the prerequisite for this talk? I try to make this hopefully approachable for everyone. So the only requirement is understanding or being able to read small Python functions as we go along. The agenda for this talk is first I'm going to introduce the four terminologies of different parts of a testing suite. Then we'll talk about how do you actually go about running it and what does it mean to get test coverage and how to actually get it. And I'll talk about tips and recommendations. And then, of course, summarize and then make recommendations for where to go from here. I'll also pause along the way so that if you have questions, you can also, type them in the chat or in the Q&A. And when we'll come to a stopping point, I'll read them aloud and answer them. So let's get started first of just what's a testing suite? As I mentioned, you've been asked to potentially write one. Your code probably has what I'll call an existing code base. You have a bunch of Python scripts, which either were exports from a notebook or you actually had a bunch of, you code in Python in .py files and you have one or more of these files that, for instance, read in a data set, do some data processing, fit a predictive model, and then make recommendations. For the sake of this tutorial, again, I do find it harder to share or follow along when there's a lot of code on one page. So the example one will be, we'll go back to this one to talk about how do you write a testing suite for this, but I'll actually walk through applying and explaining the four tests for a very, very tiny Python script / code base. It has only 5 lines. We're going to be looking at how do you say how much something costs after applying a discount and applying taxes. So in our case, our code has no functions because, usually with machine learning model development, it's a POC, it tends to be in a Python notebook, and, it's a kind of exploratory analysis that looked promising, and then we were asked to productionalize it. So again, we have no functions, and that's fine. And let's just dive right in and actually talk about the first type of test. So the first type of test is a unit test. And the unit portion of it says it's the smallest part of the code that you can test. The one caveat is it has to be a function. So in our tiny example, since we don't have any functions, the easiest, simplest way to do it is throw your whole code into a function, and then you can test the inputs and outputs. So in our case, let's say V0 for our model or for our code is throw in the 2 lines of code into a function, call it good for now, and then test that. So for a function, we know that part of it, we have to define what it's called. And in this case, since it does 2 things, it's going to be called price after discount and taxes. It takes 3 arguments: what the price of the item was, what the discount is, and what the tax rate is. And then it has our 2 lines of code that actually do the calculations, and then it returns the final price. So one unit test might be, okay, well, let's apply this function to an input, to a set of inputs, and see what the output is and check that it's the same. So in our case, you usually try to have each function start with the name test, and then what the function name is, and maybe a couple of other details, so that as your test runs, and we'll talk a little bit more later what that means, you'll get more meaningful output, so that if something breaks, you'll know which portion of the test to look at to tell you what happened. So in our case, we expect to see a price of 82.5 or $82.50, and that's given if the item originally cost $100, we had a discount of 25%, and then we have a high tax rate of 10%. And so the fourth line of that says, what we want to do is check, did the input that we feed into our function, the price after discount and taxes, did we get the result that we expected, which was $82.50? And the reason why we have to use this absolute value less than something else is because sometimes numerical representation on the computer, it might look like 82.5, but sometimes it might look like 82.500001 or 82.499999. And for all intents and purposes, we just say, okay, that looks about the same. Our test passed. So I'll stop right here, actually, and check to see if there are any questions on unit tests or code, anything else before we move on. So feel free to add this in the Q&A or chat. And I'll wait for a little bit. Okay, I think there's no questions for now, so I'll keep going. So as I mentioned before, our one function had 2 things that it was doing. And so it was a little bit hard to test to figure out, if something broke, which part of the code was it, for instance, and again, this was just 2 lines. Maybe an easier way to do it is to break up the one function into 2, and then those 2 would be 2 separate candidates for 2 separate unit tests. So the rule of thumb is, if you're writing a function and there's an and somewhere in the doc string or in the function name, that's a candidate to refactor or reorganize your code to make it simpler. So in our case, we can make 2 functions, one that says, okay, I'm going to apply a discount to a price and then return it. And then the other one says, I'm going to increase the value of our item by a certain tax rate and then return that price. So now that we have 2 functions, we can have 2 separate unit tests. And so one way to do that is very similar to how we did it 2 slides ago, is now we have one function, we say, hey, we expect to see a discounted price of $75, given that in line 16, the inputs are the item cost $100 and the discount was $25. And then again, line 17 says that we want to check how is our expected price very, very similar to output price. And we can make this value to be, let's say, 0.001 or some other value. And then we would test the other function similarly. Price after tax would have a similar unit test. But now we have 2 functions. What we can do is check, do they actually perform as expected together? And so then you can use an integration test. So that's for 2 or more functions to see, does the output of one that you send to the other one, how does that align? Does that work? Do you get to see the output that you expect? So in this case, we still have our two functions that we refactor our code. We had 2 functions. And then our integration test, what it does in line 10 is call the first function. And then in line 11, sends that result to the second function and then checks, is that, so in line 12, it checks, is the output from both of them the same as what we expected? So again, as we saw before, when we just had one function that does 2 things, we did want to see an output item price of $82.50. And so first we want to see in line 10, what that value was calling the first function, and then what that value was calling the second function of, getting our price after taxes, and then again comparing that to the values that and did we get the answer that we did. I'll stop here and see if there's any questions in the Q&A or the chat. Let's see. Okay, there's one. Let's see. Let me stop sharing to see the Q&A. Okay, so that's a good question. How many values you should test? So one thing that I'll talk briefly about that a little later, but I'll address that part of that right now. So one thing you want to do is you want to check all edge cases. So for instance, can the values be negative? Can they take, what other formats do they take? Does the function take a list, or does it only take integers, or take integers, and what does it do when it's a list? We'll talk about parameterized tests that helps you test the same function with a lot of multiple inputs. And we'll also talk about testing pyramid that says unit tests, you should have a lot more unit tests than other types of tests. But I will say I've definitely gotten into discussions with coworkers. I do find, testing design, how many tests, what to test, it is an art and a science. And I've definitely gotten feedback from coworkers that I had too many tests in our code and I should take stuff out. So I would say as long as you can give an idea for what inputs and outputs to expect, if there's something weird in the data, or if there's any edge cases that you think you should handle or not handle, that should be part of the testing suite. And anything that you can almost treat it also as additional documentation. I'll touch on all of these points a little bit later as well, so that, if you look at a code base, maybe if there is no documentation, you start at the testing suite and see what got tested, because those you would think are the most important parts of the code to get familiar with what's going on before you dive into, let's say, understand the rest of the code base. But yeah, very good question. Okay. So I briefly mentioned, so we have two functions. We did a unit test, we did an integration test, and then you give this to a customer, and first thing they do maybe is say, hey, I want a discount of 120%. Give me the item for free and actually give me money back. And that may or may not be a valid ask. So one thing we may want to do is say, oh, well, that was actually a bug. We shouldn't have been able to handle arbitrary percentages. They should always be smaller than 1. So one of the things that we can do, what that's called is, so then it's a bug in our code, and one thing we can add is what's called a regression test. So in this case, regression is not the same thing as linear regression. It's a regression in the sense that you don't want the bug to come back. So if you already fixed something, you write a regression test to check that that was fixed, so that later, if this bug comes back, what that means is it actually wasn't completely fixed. So in our case, what we'll do is if somebody, asks for a discount of more than 100%, we'll actually want to throw an error in line 8 to say, hey, this is not a valid value, throw an error, and otherwise actually give the discount. So then what our regression test will look like actually is we will check that it actually raises an error when it gives the value that invalid value. So in line 34, what it says is we're going to raise, and in this case, in line 8 above in our function, it said value error, and so we want to make sure it raises the correct error type. And then in line 35, we call our function with one type of a valid input. So that what will happen is this test will fail, but we will mark it as I expected it to fail. That was actually the right situation for that to happen. So at this point, we fixed a bug in one function, but we had 2. And so then we would have to copy paste the code in the second function, and then we'll have to remember whatever you do in one to the other. By this point, you may have noticed that the functions were really, really similar. So whenever you feel like you have to copy paste something, you shouldn't do that. So it's called dry, don't repeat yourself, because you'll at some point inevitably forget that this code was copy pasted 2 times. And so what you should do is actually refactor your code to make sure you only need to make this update once. So what we can do is combine our price after discount and price after tax into one function that is a little bit more general and just takes in a price and the adjustment. And if the adjustment is negative, then it's a discount. And if the adjustment is positive, then we can treat it as a tax rate. So now what we can do is only then test one function. And one way that we can test multiple things, so if you wanted to test multiple inputs for the same function and you don't want to be copying and pasting kind of the guts of the function, one way to do that is with a parameterized test. So at the top is again our function, and what the parameterized test does is you specify all the arguments, all the inputs and all the outputs, and then it'll run those for you. So for instance, in lines 41 through 46, we actually specify, I want to be testing 5 different scenarios. So in the first one, line 41, we want to make sure that if somebody says, I want an item with a discount of 125%, the function throws an error. And if somebody wants to check what the price of an item is after a tax rate of 40%, so in line 45, we get the right output. And similarly, in line 46, if somebody wants to apply a tax rate of more than 100%, we also should have the function throw an error. So then what the middle of the function then does, so line 53, 54, says for each of those arguments that we specified in line 41 to 47, put those scenarios into our function, compute the output, and check if that value was what was expected that we specified in the lines 41 through 47. And so what it will actually do is it will run what will look like 5 different unit tests just by using the same kind of the same function, but using different arguments. And I want to stop here and see if there's any questions before we talk through tips and tricks. Okay, let's see. I see one. Oh, okay, so it was the same question. Okay, no new questions. Okay. So now we've learned about 4 different types of tests. How do you actually run it? And how do you get code coverage? So one of the ways that you can get a testing suite to run is have this folder structure. At the very top, you have the project name. So in the screenshot that I show you, for instance, you can have a folder called price adjustment. You'll have an init file in the subfolder that tells you, are there certain constants that you might want to define? So for instance, here I've defined this round off error to compare when one value is similar to another to be 0.001. You also have your code base or multiple Python files. So in this case, I just have one file that's called adjust price. And then you have a separate folder that's called tests. And the test also has an init file. It's usually empty, but if there's certain things that only apply to the tests, you may want to put that in there. And then depending on how big your testing suite is and how many files are in your code base. So if there's only one file, you may just want to have one file that's called test adjust price for the unit test and then test integration adjust price. If you have multiple scripts, so code base 1, 2, 3, you may want to have a folder that says this is the unit test folder and then say test underscore codebase 1, test underscore codebase 2.py, and so on and so forth. So it's a little bit more organized. But once your code is in this structure, what you should be able to do is if you navigate in your terminal to this folder, or in this case, let's say price adjustment, you can clone and download this repository and it'll have all the code that I've shown on the screen. If you navigate to this folder price adjustment and run the following command to say, hey, pytest, run all the tests in my test folder. And the qualifiers say, if the test fails, break at the first one. So that's the -x. And then --PDB says, open the debugger so that I can actually step in and see what happened. And -V says verbose output so that you get to see the parametrized test, what values it actually ran. So in the screenshot below, we only wrote what looks like 4 different tests. So one that says test price adjust discount, test price adjust tax, test price adjustment discount throws error below 0, so it's passed. Then there were 5 that were parametrized, and there was 1 more that was test price adjustment integration discount. So we wrote 1, 2, 3, 4, 5, and it actually got converted into 9 different ones with not much more work. So that's nice. And then it also told you that 7 passed and 2 failed, but they were marked as fail, so that's good. And then it tells you how long it took, which is nice. So hopefully here it took less than a second, which is very nice. Otherwise, you know, if it takes an hour or 2, the longer the test run, the less people may want to check, run the testing suite, because, you know, you want to make sure that it finished before you add a new code, for instance. And the note is that one thing to notice that if you have this testing suite, you can potentially configure your repo to automatically run your testing suite every time code is committed. So that if you, for instance, add code and your tests break or your tests fail now, that code doesn't get merged into master, for instance, until that's fixed. So that's a good practice to have. And now that we have a testing suite, we can also check what's called code coverage. So code coverage checks how much of your code is checked by the testing suite. So if we have 100 lines of code and we have 1 unit test that checks 1 function that spans 3 lines, we're probably covering only 3 out of 100. In this case, this is a super tiny repository with a lot of tests, and we are getting 100% test coverage, which is very rare, if not, you know, extremely rare to do. But again, this is an example. One thing I do want to note is that getting 100% code coverage is not the same thing as getting 100% amazing tests. You can write tests that may not be as informative, or you know, they may not, if somebody's, if your test, let's say, passes in, you know, let's say a data set of 1,000 rows and something breaks, it's hard to debug. So maybe having a small data set of, let's say, 3 rows to better test something may be more informative. Then some more tips and recommendations. Now that we have a testing suite, we can run it. What can we do next? So as I mentioned, you can think of a testing suite as additional documentation. I say additional in parentheses because sometimes there's no other documentation. It might explain what inputs and outputs from each function, or when the function is run, to handle edge cases of, hey, maybe when my data is missing, my function still, all my functionality is there and it returns a certain result, and it explains to the user what that is. It may also explain what is and isn't handled in data processing just by what's getting tested in the testing suite. And of course, my favorite is you start writing code, you have your testing suite, things are working, you change 1 line and nothing's working anymore. So if you use version control and you have a testing suite, the testing suite will tell you which test broke, and your version control will also show you which lines of the code you changed. So then it's much easier to also help figure out and narrow it down what portion of your code broke and how do you fix it. I find iterating on that is much easier. Another thing, as we briefly talked about, is it's much easier to write tests when each function does one thing. So again, if you start writing a function name that has an and in it, or a doc string to say this function does this and that probably should be 2 functions at least. And then it's, again, much easier to write tests. I also found that it is much easier to write tests when you're doing development side by side. So what does that mean? You've probably heard of test-driven development, where you write the test first and then you write the code that does it. I found that, you know, with data science, a lot of the models are, you know, proof of concept, potentially first iterations in a Jupyter notebook. And so there's no you don't even know, is this going to be production code down the line? And so what I found, what helps me is that as I write in my Jupyter notebook, as I start writing code and I start refactoring my code to have functions, which I test in certain cells, what I'll later do is save the code that tested those functionality in a separate file so that I'll already have which inputs I put to the file, what was I testing, so that later, if that work proves to be production ready, I already have kind of a draft of what my testing suite should look like, or some of the components, so that it's much easier to add, let's say, function names than it is to also kind of the guts of what the function does. And then another useful thing that I found was that there's a pandas built-in function that helps you check if two data sets are equivalent. So it could be, do you care about the column order? Do you care about the row order? A couple of other things, which makes it really, really nice and makes it much easier to write a testing suite for data sets. So now we talked about what to test. Let's talk about what not to test. So if there's any functions from base Python or third-party modules that you had to install, you don't need to test it. So in this example, let's say read CSV. That's not on you to test. You're fitting a logistic regression. You don't need to check that the fit actually happened, that you actually were able to. You may want to check, did the fit. Did the predictions happen after the model was estimated, but you don't actually need to check the fit function itself to say, okay, well, does it take a list? Does it take a data frame? That's outside of scope because you did not develop that function. Similarly, hopefully, unless your manager tells you otherwise, I would say, if there's first-party functions that a team developed, so if one team developed one module and it has function B, you're writing module C that calls function B, it's not on you to write the unit test for function B unless that's your job. I would say if your scope of work is module C, then you may or should write an integration test for how this function B ties in with your work, but you don't need to unit test function B in your module. Hopefully that helps. Otherwise, also feel free to add questions to the Q&A in the chat. So now what to test? We talked about, the first example, it's our machine learning example. What are some examples of things you might want to add as parts of unit integration tests? So one thing is, do your functions allow different types? Do they allow missing values? What does that mean for a thing to be missing? Does it have to be completely missing? Is it an empty space? If you're doing text processing, what does that mean? What does it allow and not allow? On the feature engineering side, after you applied a transformation or multiple transformations, do each of those give you, if you transformed all of them into categorical variables, do you get the expected number of categories? Again, how do you handle missing values, if at all? Another check would be you created a certain number of features. Is it 20 features? Should we expect after we give a data set to our data processing step, do we get 20 features? Do we get a certain feature? So for instance, if my sentiment, if I've developed, I'm developing a model to predict sentiment around certain text features, does the thing that I care about show up in the vocabulary? So if I'm trying to pick out features, trying to predict sentiment around clothes, do I get clothing attributes or clothing mentions in my vocabulary? That should be a unit test. On the output side, there are a couple of other ideas that I would highly recommend. Is your output, what does your output look like? Again, if we're predicting sentiment, do you surface the probability? Do you surface the category? Do you surface it as a human readable output? Or maybe as a JSON or dictionary that says, this was the probability, this was the category, this was the sentiment, this was the model version, this is the timestamp, and a bunch of other variables. Another thing you may want to test is, I know that, different data sets might be different, but there's certain categories that you expect. If you get one type of input, you get a success. So for instance, if you give your model raw text of, I loved it, do you get positive sentiment? Or is your model, what's going on? So that if originally it did, then you updated your model, it doesn't, and that's part of your testing suite, what does that say? Another thing on the output side is what happens when it shouldn't be predicting a sentiment. For instance, this was an actual screenshot for one of my, for a code base that I've worked on in the past, where the input is, the customer is giving us feedback, it's missing a button. So it should not, that's not positive sentiment, it's not negative, it's a fact, right? It was just missing a button. And then this pipeline transform does a lot of the pre-processing steps to say, okay, let's parse the tags, format it, see where it is in the vocabulary, feature engineer it, and then make a prediction. And then so the last, so line 10, and says, I have a prediction. And then line 11 says, are we actually able to make it? And in this case, the -99 says, no, we're not able to predict a sentiment for it. And then the test says, okay, we don't expect it to have sentiment. Do you actually predict it to be the case? And if the answer is no, then the test passes. So in this case, we don't, since it's a factual statement, it shouldn't have sentiment. And so in this case, this would pass if the model behaved as expected. This already, came up in Q&A, really good question. How many tests do you write? And as I mentioned, it is an art and a science. I would say again, just to stress that if there's certain nuances in the code, or if there's nuances in the data that should be tested or at least explained, what are, again, like the missing button, if somebody gives you factual statements, how do you handle that? Or do you handle that? And then on the testing pyramid side, what you want to do is have tests that take the least amount of time, have a lot of those. And then integration tests, again, combine more than one function. So there should be a little bit less of them. And then end to end, you can think of it as from getting the data to doing the feature engineering to estimating the model or to making the prediction. That takes longer. And so there should be fewer of them. There shouldn't be zero, but there should be a little bit of fewer of them. And again, as we mentioned, if you get 100% code coverage, that does not mean you have good tests, because you might be testing something that's not an edge case, for instance, or there might not be any, or again, maybe the data sets are too big to, if the test fails, it's much harder to figure out what went wrong. So I'll wrap this up and then summarize and make recommendations. So as we learned, we should be testing our code a lot. It helps when our functions do only one thing, so it's much easier to write the unit tests and write combinations of them in integration tests. We learned that we should be definitely testing edge cases. And every time we squash a bug, we should add a regression test to make sure the test doesn't come back again. And then every time we have multiple functions, we should make sure they're still combined and work together well with an integration test. And if you see yourself copy pasting code, so if it's code, then it should be a function that you call multiple times. And if it's within a testing suite, then you should use a parametrized test so that you can pass in different arguments, and then you don't have to rewrite the actual kind of the function itself multiple times. So next steps, we covered a lot, but we still touched on just a little bit of the whole kind of gamut of what you can do with the testing suite. There's a lot of resource on this page and the next page. And there's one, Joel has a really good talk on how to become a better data scientist. There's also a Google paper on a lot more recommendations for how do you even test your machine learning framework in terms of, how do you have a test for if the distribution changed, or if, you have the same data, do the same trends come out? I'd highly recommend reading that paper. There's also, a blog post on more about the testing pyramid. I found the PyTest book really helpful, really recommend that as well. The documentations is also pretty good. There's also a podcast, and there's a couple of other resources. So one on, beginners, how do you start doing software development, and then this notion of writing tests when, black box, either you didn't write the code and you don't know what it's doing. Gray box is that maybe you wrote the code, but it's been 6 months since you wrote it. And then white box is, as you're developing the code. I also wanted to briefly mention type hints. Those are becoming more popular. So the tutorial that came out just this past week from Vicky on what are type hints. And again, I would stress that that's additional documentation. So it tells you what argument type the function allows, so that if you allow floats and lists, you can specify that. So that later, potentially, if somebody else is looking at your code and wants to add in a data frame, they will actually, your IDE, for instance, will say, actually, that's not a valid input. So that helps a lot. I didn't cover this, but wanted to, recommend this as well. There's a package called Hypothesis where you can specify the type of input and the type of output, and it will actually generate tests for you. So you can say, I want 100 tests with this float and this other float, and it will actually test your code for you to help make your code base even more robust. We didn't talk at all actually about what's called fixtures. So setting up, for instance, if you wanted to test, if your input to your functionality, for instance, could be a data set or something that, or maybe a dictionary or vocabulary object that you will want to check all your functions against, you can define that in what's called a cont'd file. And then all your tests or a portion of your tests can use that. So that, for instance, you can say, hey, my vocabulary contains 10 words. This is what they are. And then you can check, hey, when my input is a certain data set, again, that you can also specify in cont'd, when I do my data processing step, do I get this vocabulary or not? And then what mockups are is if you are getting data from a database, so for instance, to get even an input, you don't want to be in your testing suite calling your production database. So what you can do is then create tiny databases locally to be able to test your testing suite against. And then I briefly mentioned that when you have a testing suite, you can have tests running automatically as soon as you push code to repository, and that's done with continuous integration. So there's a couple of ways to do that with Jenkins, or what's called Circle CI or Travis CI for continuous integration, to be able to integrate that into your repository so that as soon as you commit something, it runs it. And if the test broke, then your code doesn't get committed. Or actually, it gets committed but doesn't get pushed to master. It'll say, hey, you actually need to fix this. And then I found this other blog for how do you review code that you don't understand. There's a lot of tips on that. And then last but not least is, now you have your code, it's ready for production, it has a testing suite. How is it actually going to be rolled out to your customer base? Is it going to be rolled out to 10% of your audience, and 20, 30%? Is it going to be rolled out to everyone? How do you do that to make sure that, you can also check on the implementation side, is the model working, is it not working? And now I want to stop for questions again. So again, if you have chat, if you want to send those to the chat or the Q&A, the slides are available at this bit.ly link. There's a GitHub link, and ideas will also, this webinar is recorded and it'll be on the YouTube channel posted, I would say within, probably within the next 2 to 3 or 4 weeks there. And then while I await your questions, I also wanted to, since you stayed until the end, I did want to offer you a free gift. I'll be giving out 5 free 15-minute strategy sessions to the first 5 people to email me. So let's see if there's any questions, either in the Q&A or chat.
So we have a new question in the chat window.
Oh, I see. Okay. How do you, yeah, that's good. So there's a question, how do you approach testing deep learning architectures? You can end up training the wrong model for quite a bit of time. So that's a really good question. I would say in part, you can treat it, so I'll give a simplified approach first. You can treat it as any other model. Just say, what inputs do you give it? What are the outputs? how is the output formatted? Is it formatted, kind of what we talked about, is it formatted in the format that you expect? I would say there's a lot of, you can potentially, depending on which framework you're using, you could be, again, saving intermediary to say, hey, this layer, this could be one function, this layer is another function. Checking to make sure that's consistent. There's been a lot more blog posts specifically for deep learning just because there's a lot more parameters. But I would say the big picture ideas are still the same, just to make sure to test any edge cases. How do you test if, again, if you have, a document, certain things are you predicting, for certain scenarios that should be of a certain case, is your model doing that or not? And hopefully that helps. And if not, feel free to follow up. Are there any other questions? Let's see. Okay, one more in the Q&A. Okay, so the question is, can you post the link to the slides in the repo via this or the chat? Yes, so I can post it. I can post it in the chat. So oops, let me share.
And also for everyone who joined the talk today, I guess we will share the slide link in our YouTube video description as well.
And I just shared the link to the slides in the repository.
All right, so if there's no more questions, I guess we will end the online talk today. And again, thank you for being here today with us. And thank you, Dr. Irina, to give us a wonderful talk.
Thank you all for attending, and have a good rest of your weekend. It was really nice talking to you. Have a good day.
All right, bye-bye, everyone.